Right, before we go any further, I want you to do something. I want you to look at your hand. Go on, your actual hand. Because what I'm about to tell you is that the hand you're looking at, the skin, the cells, the protons and neutrons in every single atom, is made, in a very real and formal physical sense, of antimatter. Not partly, not loosely, mathematically, inextricably, according to the most precisely tested scientific theory in the entire history of human knowledge. The man who proved it won a Nobel Prize. His name was Richard Feynman. And by the end of this video, you will never look at your hand the same way again. Now, most people's picture of antimatter goes something like this. It's the exotic, explosive opposite of regular matter. It's what they make at CERN in Switzerland, inside an accelerator that cost billions of dollars. It annihilates on contact with ordinary matter. It's rare, it's dangerous, and it basically doesn't exist in any meaningful amount anywhere in the natural universe. That picture is not completely wrong, but it's missing something so fundamental that getting it wrong means you've been misunderstanding the very fabric of reality. And that's what we're here to fix today. So let's start at the beginning, because the story of antimatter begins not with Feynman, but with another absolute genius who most people haven't heard of, Paul Dirac. It's 1928. The physics world is in absolute chaos in the best possible way. Quantum mechanics has just been born, Einstein's relativity has turned our understanding of space and time upside down, and the two theories are sitting awkwardly next to each other, like they're not quite sure how to get along. Paul Dirac, a young British physicist who was famously so quiet that colleagues invented a unit of conversation called the Dirac, meaning 1 word per hour, decided to do something no one had managed. Combine Einstein's special relativity with quantum mechanics to describe the electron. What he came up with was the Dirac equation. Beautiful, compact, and absolutely mental in its implications. Here's the thing. When you solve the Dirac equation, you get two sets of solutions. The first set describes electrons as we know them. Negative charge, positive energy, moving forward through time. Fine, we know those. But the second set describes particles with negative energy. Not low energy, negative energy. Less than nothing. And to stop these negative energy states from being a problem, because particles in positive energy would theoretically fall into them forever, releasing infinite energy, Dirac proposed that all of space, every corner of the universe, was already filled with an invisible, infinite ocean of these negative energy electrons. He called it the Dirac Sea. If a photon came along with enough energy, it could knock one of those invisible electrons out of the sea, leaving behind a hole. And that hole would behave exactly like a positively charged particle, the mirror image of an electron, with the same mass but opposite charge. Dirac had mathematically predicted antimatter before anyone had ever seen it. In 1932, Carl Anderson found positrons in cosmic ray tracks, and the prediction was confirmed. Paul Dirac won the Nobel Prize. Antimatter was real. But here's the honest truth about Dirac's model. It worked. It made correct predictions, but it was deeply unsatisfying to a lot of physicists. You had to imagine this infinite, invisible sea of particles filling all of space. It was mathematically clunky, it was conceptually uncomfortable, and it left physicists searching for a cleaner, more elegant way to think about what antimatter actually is. That cleaner way came from Richard Feynman. Feynman was working in the 1940s on what would become quantum electrodynamics, QED, the quantum field theory of how light and matter interact. And while doing the calculations, he noticed something extraordinary hiding in the mathematics. When you write down the equations describing how an electron moves through space-time, and you want to also describe a positron, the antimatter version, You don't need to invent a new kind of particle. You don't need an infinite C. All you need to do is reverse the direction of time in the equation. Flip the sign of time. And the equation for an electron moving forward in time becomes mathematically identical to the equation for a positron. A positron, in Feynman's interpretation, is an electron moving backward through time. And critically, the maths doesn't care which direction time flows. The laws of physics at this level are time symmetric. The positron-electron time reversal isn't a metaphor or a story we tell for simplicity. It is the formal mathematical structure of the theory. Now, I know that sounds like science fiction, but here's why it absolutely is not. Feynman built an entire framework around this idea, quantum electrodynamics, which is what we now call QED. And QED is the most precisely verified theory in the history of physics. Full stop. It predicts the magnetic moment of the electron, a tiny quantum property, to 11 decimal places. 11. And experiments match that prediction to 11 decimal places. To give you a sense of what that means, it's the equivalent of measuring the distance from Sydney to London to within the width of a single human hair. We have never, in the history of science, had a theory match reality with that degree of accuracy. Feynman's picture of antimatter, positrons as electrons moving backward in time, is not a poetic simplification. It is baked into the most successful scientific theory ever constructed. In 1965, it earned Feynman the Nobel Prize in Physics, alongside Julian Schwinger and Shinichiro Tominaga. He illustrated the theory using what we now call Feynman diagrams. These are deceptively simple little pictures of particle interactions. You draw a line for an electron moving forward in time, you draw a line for a positron, and in the diagram, it's literally the same kind of line, just with the arrow reversed. The mathematics treats them as one object with two temporal directions. It's elegant in a way that makes physicists genuinely emotional. The distinction between matter and antimatter in these diagrams is just an arrow on a line. Now here's where it gets personal, because this brings us back to your hand. In quantum field theory, the full framework built on top of QED and Feynman's work, empty space is not empty. This is one of the most important and least appreciated facts in all of physics. The vacuum of space is a roiling, seething quantum foam of virtual particles. An electron and a positron, a matter particle and its antimatter twin, can spontaneously appear from nothing, flicker into existence for an incredibly brief moment, and then annihilate each other back into energy. This is called vacuum fluctuation, or virtual pair production. It's not a theoretical convenience, it's been measured. The Casimir effect, the tiny but real force between two uncharged metal plates placed extremely close together, is caused by these virtual particle fluctuations, and we've confirmed it in labs to extraordinary precision. The quantum vacuum is alive with matter and antimatter constantly appearing and disappearing. Now, inside your body, inside every proton and neutron, in every atom, in every cell, this is happening all the time. The quarks that make up your protons aren't just three little balls sitting quietly inside a nucleus. They're embedded in a quantum field that is constantly producing and annihilating virtual quark-antiquark pairs, virtual antimatter particles, flickering in and out of existence at every moment, contributing to the mass and energy of the very particles you're made of. In fact, and this is the part that should make you stop and stare at the ceiling for a moment, the mass of a proton is not primarily the mass of its three constituent quarks. The quarks alone account for only about 1% of the proton's mass. The other 99% comes from the energy of the quantum field swirling inside it. The gluons, the virtual quark-antiquark pairs, the constant quantum field activity, including virtual antimatter. The weight you feel when you lift your hand is mostly quantum field energy. It is mostly the energy of particles that technically shouldn't exist under classical physics, but do exist under quantum field theory. including antimatter particles, according to QED. According to the theory that won Feynman his Nobel Prize, you are not separate from antimatter. You are not the opposite of antimatter. You are a quantum phenomenon that has antimatter woven into its very structure. The line between matter and antimatter is not a clean boundary. It is a quantum blur, and you exist right in the middle of it. Now here's the one enormous mystery that's still open. If matter and antimatter are this deeply intertwined, if the fundamental laws of physics treat them almost symmetrically, then why is the universe almost entirely made of matter? Why didn't matter and antimatter annihilate each other completely in the moments after the Big Bang, leaving nothing but light? The answer seems to be that there was a tiny, tiny imbalance. About 1 part in a billion more matter than antimatter was produced in the early universe. That imbalance is why everything exists, why the Earth exists, why you exist. But we don't fully understand why that imbalance is there. This is called the baryon asymmetry problem, and it is the biggest unsolved mystery in fundamental physics. Right now at CERN, the BASE experiment, the baryon-antibaryon symmetry experiment, is measuring the magnetic properties of single trapped antiprotons with extraordinary precision, looking for any tiny difference between matter and antimatter that might explain that asymmetry. In 2025, the BASE team achieved coherent control of a single antiproton's quantum spin state for the first time ever, a massive technical milestone, and we are getting genuinely closer to an answer. But what Feynman's Nobel Prize-winning theory already tells us, with certainty, with 11 decimal places of certainty, is this. The picture of antimatter as a rare, exotic, alien substance that only exists in billion-dollar accelerators is wrong. Antimatter is not the opposite of matter. It is a part of matter. It is a part of you. Every particle you're built from is defined by its relationship to its antimatter counterpart. Every atom in your body exists in a quantum field that includes virtual antimatter particles at all times. You are, in the most rigorously tested scientific sense of the word, made of it. Feynman once said that if you think you understand quantum mechanics, you don't understand quantum mechanics. I'd extend that to antimatter. If you came into this video thinking antimatter was just the stuff that blows up when it touches regular matter, you now understand it a little more the way a physicist does, and a little more the way the universe actually is. If this video did something to your brain, smash the like button and subscribe. There's heaps more where this came from, and we go this deep every single time. Drop your questions down in the comments. I read every one of them. And if you've got a mate who reckons they know what antimatter is, send them this. See what they reckon after. Cheers.